children to my tutorial again. So as I have told you that about the matrices in my previous video, today also I am going to teach the next part of the matrices, and before teaching I want to do one request again, that please subscribe my channel, like it, share it and press the bell icon. And again I am telling the important thing to you children, watch my video full so that you will get the next video, which is the sequentially it will come from every chapter. So watch my video full. So if you want more assistance from my side also, more solutions from any book, so you can contact me in my WhatsApp number what has given in the description box. I will give you every assistance whatever you need. So children, now we will go to our topic, that is the second part of the matrices. Hope you understand it, whatever I have taught in the previous class. Now enjoy it and do it, and by making the fun. So before going to this type of matrix, just I want to remind you what I have taught in the previous class, that is the different types of matrix. One is the row matrix, second the column matrix, then square matrix, then rectangular matrix. Then the other form of matrix is the zero or null matrix. So that does not matter that whatever the matrix, maybe it is row, maybe it is column, or maybe it is rectangular or square, if the elements of a matrix is 0, means each and every element of a matrix is 0. Now see that one, 0, 0, 0, 0, or only 0, 0. Or it is the 0, 0, 0, 0, 0, 0. So here you can see that every element of a matrix is 0. So that time it is called the zero or null matrix. Means what is the definition? That each element of a matrix is 0. Each element is 0. Then it is called the zero or null matrix. Now children, the another form of matrix is diagonal matrix. Diagonal means you can understand, if it is a rectangle, then diagonal is like this or diagonal is like this. If it is in the form of a square, then also diagonal is like this or diagonal is like this. In this format only, if in a matrices the elements are is like this, or the elements are is like this, or the elements are like this or like this, then only it is called the diagonal matrix. Then definitely a question arises in your mind that then what about others? Means it is in the rectangle, so your matrix is in the also rectangular form, and if it is a square, your matrix can be the square matrix. So what about the other elements? Now let's see. Suppose one matrix is 1, then it is the 2, then it is the 3. Suppose it has written 1, 2, 3. Means in the diagonal it is the 3 elements are there. So it must be a 3 into 3 matrix. That is, here is 0, 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 it is 3. So this is known as your square matrix of diagonal matrix. Means here as it is in the form of a square matrix, means 3 into 3 order, it is the order of 3 into 3, but except the diagonal all elements are 0. Like this, suppose you have to write like this, you can write that 1, 2, 3. Suppose this is like this, so you can put 0 here also, 0, 2, 0, 3, 0, 0. So it is also in the form of a diagonal. So this is also 3 into 3 matrix, but this is also called a diagonal matrix, because except the diagonal all the elements of these matrices are 0. So that is called the diagonal. Now go to the definition of the diagonal matrix, that is the whose all elements are 0, all elements are 0 except the diagonal, that time it is called the diagonal matrix. Now go to the next type of matrix. So children, here I have done the both the type of matrices, 3 into 3 and 3 into 3. But if you will take in the rectangular form, as I have done that rectangle is also a diagonal. But if matrix you are taking the rectangular form, means see here as I am taking, suppose that is the 1, 0, 0. and I have to write middle, but here I cannot get a middle if I will do the rectangle. Means see, I cannot put here suppose 0, 0, 2. That also one element is missing. It is not the diagonal. I cannot put, no number is there. That is the, it is not. So we cannot do the diagonal matrix in the, we cannot do the diagonal matrix in the rectangular matrix. So only diagonal matrix can be done in the square matrix, not in the rectangular matrix. Now children, the next form of matrix is unit matrix. So unit matrix is the abstract form of the diagonal matrix. Means there unit matrix is also a diagonal matrix, but in diagonal matrix any number can be there. But unit matrix, the number only 1. Means in the unit matrix you will get the elements that is 0 or 1. Now see that you can do that 1, 0, 0. 0, 1, 0, then 0, 0, 1. That means the diagonal is like this 1, 1, 1 and other elements are 0. So as it is a diagonal matrix, but the elements of the diagonals are 1. That time it is called the unit matrix of order 3 into 3. But remember again that in the rectangular matrix also unit matrix is not possible. Now we can do the 4 into 4 matrix also. 1, 0, 0, 0. Again one is the 0, 1, 0, 0. Then 0, 0, 1, 0. Then 0, 0, 0, 1. Now also you can say it is the diagonal of the 4 into 4 order. So all are in the form of square matrix only, and the diagonal elements are only 1. So you can see that diagonal elements are 1 and other elements are 0. Other elements are 0. So this is called the unit matrix. So children, this is all about the types of matrices. Now the next concept is what is the transpose of a matrix and equality of matrices. Now let's see about the transpose of a matrix and equality of matrix. So children, this is the another concept, that is the transpose of a matrix. Transpose means what? That is the interchanging the rows and the columns. Interchanging the rows and columns. Let's see one example so that you can understand easily. It is the suppose 1, 2, 3, 4. So it is a matrix order of 2 into 2. So now you interchange, as you know that this is the row, this is the column, and this is the row, this is the row, this is the column, this is the column. It is telling that interchanging the rows and columns means you have to put the column elements into a row and the row elements into a column. So what is the transpose of a matrix then? Transpose, that answer is that one. You have to do 1, 3, 2, 4. That you interchange it. 1, 2 it is the row, you have to make it column. 3, 4 is the row, you have to make it column. So that is known as the transpose of a matrix. So children, if you are taking this matrix as A means only the name. Whatever you can take, let A is that one. So how to denote transpose? That is capital A. That in the above whole it is the small t, means AT equal to 1, 3, 2, 4. So this is all about the transpose of a matrix. Again you remember, you have to interchange the rows and columns if you want to find the transpose of a matrix. Suppose again I want to find this transpose to A. AT again transpose of matrix means again you will get the matrices, again the original matrix. That is how it is. Suppose AT, that is again T, means how you will get, again you interchange it, that is the 1, 2, then again 3, 4. That answer is the A. So this is known as the transpose of a matrix, only interchanging the rows and columns. Now children, next concept is equality of a matrix. Equality means from the name only you can understand that both the matrices are equal. Equal means on which basis they are equal? They are equal on the basis of their rows, on the basis of their columns, and very interesting part is their elements are also same. Means like this everything is same. Suppose A is a matrix of order 2 into 2 means it is the row, it is the column. So if you want to do a equal matrix, suppose that is B, you have to make also a 2 into 2 matrix. That means the row same and column same, the row same and column same. Then what about the elements? As I told, column elements are also same. Means if you are writing 1, 2 and 3, 4, here also you have to write 1, 2, 3, 4. Means here order also same and your elements also same. Now let's see another one. Suppose another one is that is the 1, 2, 3, 2, 4, 5. So suppose I want to do, so what is the order of this matrix? As you know that is the 3, that is the 2 into 3 matrix. So here if you want to do the equality of a matrix, suppose another matrix, that must be order of 2 into 3 and also the elements are 1, 2, 3 and 2, 4, 5. Then only the corresponding elements, means what is the corresponding elements here? I am writing again. If A equal to 1, 2, 3, 2, 4, 5, then B equal to, that is the 1, 2, 3, 2, 4, 5, means corresponding, means 1 is the 1, 2 is the 2, 3 is the 3, then 2 go 2, then 4, 4, then 5, 5. So these corresponding elements are equal. That time it is known as the equality of a matrix. Then writing the conditions of the equality of the matrix. Then what is the definition then? That if two matrices are equal when both the matrices have same order, and second condition is their corresponding elements are also same. Their corresponding elements are also same. So children, this is all about today's lecture. Hope you understand it. So next class we will read about the operations on the matrix, that is the addition, subtraction, additive identity, additive inverse, etc., etc. So hope you like this video. So if you like it, then don't forget to like, share and subscribe and press the bell icon and watch the full video to get the full chapter in the sequential wise. So do it children, and hope all be safe in this corona situation, lockdown situation. This is my a step to reach you, to give your explanations properly so that you will get benefit from it, and thank you very much.